Hey guys, today we're going to be talking about topic 5 of IB Computer Science, Abstract Data Structures. Our focus today is going to be on trees, and we're going to cover points 5.1.14 to 5.1.17, which is all about how trees operate logically, the key terms used in the tree structures, and how traversal works, and how to sketch binary trees. So to start, what is a tree? A tree is a non-linear data structure made up of nodes, where each node stores a value and potentially links to other nodes. At the very top of the tree is the root node. This is the starting point. Each node may have 0 or more children, and those children may have their own children, forming a branching structure. In a binary tree, each node can have at most 2 children, a left child and a right child. This constraint makes binary trees predictable and easy to work with. We use trees in many real-world applications. Your computer's file system is a tree. A decision tree in AI uses this structure to make choices, and binary search trees help us quickly search and sort data. So trees give us both structure and efficiency. So now let's break down the key terms you need to know. The first is the root is the topmost node. It has no parent. A parent is any node that has one or more children nodes. A child node is a node that comes from another node. It's connected downwards. A leaf node has no children. It's at the edge of the tree. A subtree is any node and all of its descendants. Imagine cutting off a branch of a tree. That branch is a subtree. In a binary tree, each parent can have up to 2 children, a left child and a right child. These terms aren't just definitions, but they're also used in IB pseudocode and tree traversal problems. You'll need to recognize and label them in both diagrams and explanations. So let's walk through a basic tree and label these terms together. So if we had a tree like this, then we had, the root node would be A. B and C are the children of A. B is a parent of D, and C is the parent of E and F. Oh, I've drawn this wrong. So B is the parent of D, and C is the parent of E and F. D, E, and F are leaves, as they don't have any children. And if I ask for the subtree of C, that would include C, E, and F. So now let's look at the different tree traversal types. In computer science, traversal means visiting all the nodes in a tree in a specific order. There are 3 standard methods that the IB expects you to know, and they all relate to binary trees. In-order traversal, which goes left, root, then right. Pre-order traversal, which goes root, left, right. And post-order traversal, which goes left, right, and then root. Each one has different uses. In-order is often used for binary search trees because it visits nodes in a sorted order. Pre-order is used when you want to copy the tree or evaluate an expression. Post-order is useful for deleting or freeing memory since it visits children before the parent. These often come up in paper too, so it's important to be able to trace and write the output for each one. So let's walk through each traversal using a new tree. So if we had our parent node, our root node A, which would be the parents of B and C, and B is the parent of D and E, and C is the parent of F. This we already know. This is a tree we're going to use to go through each type of traversal. Now let's go through the output of each traversal using the tree we just drew. In order means we visit the left subtree, then the root, then the right subtree. You can imagine it like this. If we're doing an in-order traversal, we would have flags at the bottom of each node. So when we're going through, every time we pass one of the flags, we would add it to our list. So if we were doing in order, it would become, we go along, you get D, then B, then E, then A, then C, and then F. If we were doing a pre-order traversal, it means we start with the root, then left, then right. Order. Pre-order, we can put our flags on the left side. So then this would look like A, then B, then D, then E, then C, and then F. Now the final type of binary tree traversal is post-order. In this case, we would put our flags to the right of each node, like so. So when we go through, we would have D, and then E, and then B, and then F, then C, and then A. You should practice each of these until you can trace them confidently without drawing arrows. They're extremely common in IB past papers. Finally, the IB expects you to be able to draw binary trees and understand how they're structured. Here are some exam tips. Use levels clearly. Each level should branch from the previous. Always position the left and right children consistently. Don't cross wires or flip them. Always label the root, leaves, and subtrees, as it can often help you understand what's going on in the tree better. And practice writing trees from inputs or pseudocodes, for example, building a tree from a pre-order list. Also, remember, trees don't need to be perfect, just correct. The structure is what matters, not perfect symmetry. So to wrap up, trees are hierarchical structures built from nodes. You should be able to define the terms root, parent, child, left child, right child, leaf, and subtree. You must know how to do in-order, pre-order, and post-order traversal, and how to output the correct sequence. And you should be able to draw binary trees clearly and correctly. That's everything for 5.1.14 to 5.1.17. Thank you.